Just it's briefing how the system are working. And then through that, you'll, through the bus bar, it will be distributed through circuit breaker, and then motor controlled, and then going for each system alone. Then you will have the lighting system, you will have all the main systems. Also, you have also the transformer on board will be the same. And for our backup will be the emergency. The emergency will have one separate emergency generator. It is connected through one emergency switchboard to some critical equipment, what will be required to sail the vessel, to allow the vessel to sail, like steering gear, emergency pillion and fire pump, the water tightening doors, the fire system, the navigation, lighting, the communication, and the alarm system. And for that, to have all the system working and safe to use, we have to scan. We have to plan our dry dock. So really, the dry dock is what it's the opportunity to take the vessel outside the water and to check the integrity. If all the systems are working or not, it's one stop to perform the maintenance for all these systems. And during the dry dock, it will be like some new join, yeah. During the dry dock, this period will be very stressful for the crew who are working on board, because they will be loaded. They will have people coming and going. There will be technicians working on board. They have to deal with a variety of surveyor and inspection, and there will be also high risk. They will be solicited day and night. They have to go for a paperwork and permit to work and final report and so many others. So for that, we need a good preparation, a good planning. So for the docking, and the dock is divided in two periods: the docking and the berthing. Because the berthing, we have some job to do, and during docking, during dry dock, or it will be, we have another scope of job to be done. So, and this dry docking is also part of regulation from SOLAS, and it is mandatory to go, for example, every 2 years, 3 years, 5 years, depend on what kind of vessel we are having, to go through it, to inspect, because during dry dock we have so many things to be inspected. So what will be our preparation based on what? How we can start preparing our dry docking scope? So the preparation will be based on the previous, because we have to go through all the documents from previous dry dock. We need to check all the report, what is done, what is not done, what remain, and after that we have to check the integrity of all our equipment. We have to record the failure, and we have to have the running hours for every equipment, and then to plan what equipment required to be done during dry dock, because not all equipment will be done during dry dock. Some of them can be done even during sailing period or at berthing, but only the critical items. And what we have to use the opportunity of having a vessel outside the water, or there is no power on board to perform this maintenance. For that, we need some input data. One of the major input data, you must have the record for the vibration. It is mandatory to perform it at least once a month for all our motors, or our running equipment, rotation equipment, to have the record of vibration. And we must know, because the vibration can give you the forecast for the next, for example, maximum one month. If you start having some failure, so you can just tackle it and sort it out. So this, as chief engineer or chief electrician working on board, you must have this kind of record. The next, you must have your thermographic survey before entering the dock, because The most common failure, and it's like a ghost failure, having a loose contact or having earth leakage, fault ground fault. This is like a ghost problem. You can't catch it. You can spend days to find it out. So the only method to perform this is to go through thermographic survey. Run your equipment for 1 hour, almost all the equipment, and get your infrared camera. Ask one third part to do it for you if it is helpful for you, or if you cannot define how to do it, and then performance. And you will see where we have issue and where we have failure and where we have a loose contact. This loose contact can make a disaster if it's not sorted out properly. And then it will help you which equipment are more loaded than the requirement, and which equipment required to be fixed. Especially for the main switchboard. The main switchboard you cannot open during sailing of the vessel. You can do it only when there is no power, because there is bus bar inside, and it is high risk. No one can touch it if there is power inside. It can be electrocuted. So the only option, the specialist team, they can take the thermographic survey and check where you have a loose contact. Then you must have the mega reading of all your motors, all your switchboard, all your any equipment connected to your network must go for the mega reading and record it. Do it monthly. Try to have your record on monthly basis, and then you will monitor if there is any fluctuation on the record. If it is going high or if it is going low, then you know that some failure is going to happen. So you prepare your forecast, and then using the docking opportunity to start preparing, to start overhauling this equipment. For example, if you are having your alternator, the main alternator, the mega reading is going down. So there is some failure happening, some contamination. The wire insulation will be damaged. You will not just catch and clean it and apply another varnish layer to protect it. So this is the way how we collect all our input data to prepare our scope. Gentlemen, if you have any questions, just stop me and let me know.
No, sir, it's okay. Yeah, the info is clear.
Perfect, thank you. Okay, more than that, so we told we have thermographic survey, we have the vibration, we have the mega reading, we have the previous dry docking what done, we have record of all running hours, we have the major defect for our equipment. We must have the record what can be sorted out, and what if you can find out the root cause for any defect, just you have to highlight this failure during dry dock and try to sort it out. And any defect without root cause defined means it will come again. So we have to sort it out during dry dock. Dry dock means you will have some experimented people who will help and support you to find out the root cause and to have your equipment safe, running safely. One more thing. As chief engineer, you will have all your schedule for maintenance, and some maintenance can be at certain level, and some others will be at the highest level. So it also, if it can this highest level maintenance to be scheduled during dry dock, it will be an add-on. Okay, when you prepare your list, you have to sit with your superintendent, and because it will be another discussion, because you have to convince him why you need to service all this equipment. And it will be now discussing about money-wise and convince or not, and what will be approved to be done, what will be not, and then this is another headache. Going further now, if everything is agreed, as a chief engineer on board, you must have your single line diagram in your head. You must memorize this one in your head directly. So this is a single line diagram. Here you can see how the power is generated and how it is distributed and what kind of equipment you have on your project. So for example, for this one is typical. This is a typical system. We have 3 generators running, we have 2 generators running, and we have 1 emergency. And you must be able to define which one of them, the main generator, which one is the emergency generator. And then you have the main distribution panel. And you start having your motor controller. And what kind of network you have? You can have your 440 network, your 220 network, your 110 network, your 24-volt network, because all these are equipment, existing equipment on board that require power supplies. So we must have it. And some equipment are connected directly to the main switchboard. Some other are connected through another motor controller or transformer. Going further on, so now let's discuss about our power source on board. As you may know, on board we have several types of power source. The first of all will be the main generator. This is our main power source, and it required, so some are running with diesel, some are running with fuel, so many kind of power of generator. And then after that, we will have, this is the power generator. This is how it is on board and how it is on foundation attached to the main engine. The other source of power will be the shaft generator. So the shaft generator will not be connected to one engine. It will be connected to the shaft, the main propulsion shaft, through through one gearbox. This is another source of power on board. The third one, you will have the 24-volt. This is your backup for all the communication system. So this is mandatory to have it on board. The last one will be your emergency generator. And you can see the difference between emergency generator and the main generator. It's having a radiator. So the emergency generator is having a radiator. The starting system will be will be by battery. So it will not require any air starting system. It will be independent. In case of any failure of all equipment on board, you will have the final one will be the emergency, and it is to run through battery. And even for cooling, you will need it's with radiator, not through some circulated cooling line. Clear, gentlemen? Okay. Now there is two types of generator. The one designed with ball bearing and the one designed with bobbin bearing. The difference between them is the ball bearing are the generator required after running hours to replace the bearing. The bobbin one are not. So to prepare your plan, you must know your generator is ball bearing or bobbin bearing, and how many bearing you have, and how many running hours already for. And then you must have your spare part on board. Sometimes it can be this bearing are not common or available. So you must, before going to the dock, you must prepare it. You must have it. More than that, I don't know if you have idea about how the alternator is working or not, and what is the component of each alternator. Jens?
Yes, Saudi.
Do you have a clear picture and idea how the alternator is working, gentlemen?
Remember the parts of it, just not the clear picture, but for me, no.
For you, no. Okay. I will go to the next page. You will have the more clear picture about the generator. Okay, here you can see the generator. This picture is clear for everyone?
Yes.
Okay, so I will focus on this diagram. You can see we have the rotor This is the turning part, and you have the stator. This is the static part. We start the rotor will start producing power. This power from the 7. This is the rotor. This is our main rotor. 7 is our main rotor. This is the part number 7. This is our main rotor. It will so we will start from 0. We'll start from the 7. 7 will start. Will make some magnetic field. This field going through the stator. You will, when you apply field on any coil, you will have output. So from at 8, you will have some output. This output, we will monitor it and control it. So we will monitor the output and control it by what we call the AVR. It's like electronic PCB. You have the input, how much amperes going through the alternator, and what is the output voltage, and it will be set. So we set as per our requirement. If, for example, if it is 440 volt plus and minus 5 or 3%, and then what will be the output, not to exceed. Otherwise, if we exceed it, the AVR will directly cut power on this alternator. Otherwise, it will be damaged. And then the AVR will give power. This is the AVR will provide power to the exciter coil. When you have the exciter coil excited, so we will have a field there, and then the number 5, the number 5 will be the rotor of the exciter, and we have some output. The output will be rectified through the diode number 6, and then injected on number 7. And vice versa, you will have your cycle. A little bit Chinese. Okay, here we are having our ball bearing alternator. This type of alternator is there is ball bearing and bobbitt bearing. The ball bearing, you have one with 2 bearing, and you have one with only 1 bearing and harmonic plate. This is the harmonic plate when my mouse is moving. So it is attached to the engine with harmonic plate. With 2 bearing, it will be attached with rubber coupling. 80% of the alternator are ball plate. So this is the type. If you go for example, the Caterpillar one, wherever you have on board or any other, it will be with harmonic plates directly coupled with the alternator. And then you can see your exciter. The rectifier, the diode, will be mounted directly. If we can make another session, and they will explain you especially about the alternator, how it is working. The AVR will be one PCB, as you can see here, attached, and then we have our wiring to control it. The only bearing will be from backside at this end bell. This is the only bearing what will be existing on the alternator. From this side, it will be directly coupled with the engine. Our second type, and most of the VLCC vessel, they are having this type of alternator with bobbitt bearing. What do we mean by bobbitt bearing? It looks like it's not like normal bearing, and it is like it's made for life. This kind of bearings, so it's not required to replace them, but we have to maintain them properly, and it is lubricated by oil. So you will have 2, one in front and one at the back. So one drive side, one non-drive side. And to make this alternator more sealed, they are using like a cooler. So it will be water-cooled alternator. There will be one forced fan to circulate the air inside, as per this picture, the number 10. This number 10 is like a cooling. Some water will go inside, and then forced circulated air will go inside to cool. So you will not have any oily, or because the engine room environment is oily and dusty environment, and it will go inside everything. And the IP of any of the alternator is low. We are discussing about IP22. You know what IP does mean? Gentlemen, IP is the protection for every equipment. it's coming in 2 digits. The first one is for dust. The second one is for water. IP22 mean it's like it can't resist on dust. Dust can easily go inside, and even splash of water easily can go inside. For example, for the submerged one, IP will go up to 68 or 69. Okay, we will focus more on this alternator overhaul because this will be one of the major tasks to follow after it. If any, the most critical equipment on board the vessel will be the first one will be the generator. So this is how the first thing will be to take the air gap. So, and this air gap is because you have before the mega reading, and then with the air gap you can define if you have any problem with your alternator. The air gap is to check, as you can see in this picture. You will use a feeler gauge to go between rotor and stator, and to check if it is the air gap. The air gap is the same all around the rotor, between rotor and stator. It is the same or not. If we have some fluctuation on the air gap, the rotor will touch the stator, and we will have some wrapping. And then we can, this is the sign of rotor is a little bit bell, or the end bell, because the end bell are having the bearing. There is some damage, and the bearing is a little bit lowered down, and or we are having some misalignment. Because, for example, if you are going for the first alternator, this one, you have only one bearing from the non-drive side. Going to the drive side, you have no bearing. So easily, if there is some misalignment here, the rotor will touch the stator, and you will have some debris and wrapping, and your alternator can be damaged. So recording the air gap is mandatory to check if your equipment is safe or if you have any failure or not. After that, if you have any failure, we have to draw the rotor, take it out. So as you can see in this picture, we are drawing the rotor. Just a minute, I want to discuss one more thing. As chief engineer on board, you must have the procedure of dismantling your alternator. You must have the procedure, what PADIs will be required to dismantle, what access job are required. Because if we go for, I will go to previous picture to show you more. Okay, here, this is your main alternator on this picture. Have you seen how it is hanged on top the foundation? There is some duct, there is some cables. So how you believe it will be, what will be the procedure to take this alternator out? The yard will come with this proposal, but as chief engineer, what will be your proposal? And you must prepare before. What will be your hanging and rigging plan? Same for the shaft alternator. Check how the space is conducted. So you must know exactly what will be the procedure to take this alternator out. Sometimes we can't take it. We have to do it in place. We have to dismantle everything and do it in place. So we will draw the rotor and do the cleaning in place. Okay, so this is our overhauling process of the alternator. And then you have to be on top of every single measurement, and you must have the reference from the manufacturer for what is the tolerance of each record. Now for the bobbit bearing. The bobbit bearing are it's soft, and it's soft material. It's kind of aluminium, so many other composite material there. And then, since it is soft and we are giving only oil to lubricate, so any damage you can see it like in this picture. So when we open the alternator to check, the first thing we have to see if there is wrapping, if there is cracks, and if it is safe to continue use or not. And it's not like the ball bearing you have to throw it. This one can be repaired. So this white metal can be built again and can be machined and can be set. So it is made, like I told you, it's made for life. So Even you have some damage, like showing in this picture, it can be fixed. So you can save your bearing. But the question is why you reach this point. So what you miss in your maintenance, in your preventive maintenance, why, to reach this point? Because normally this kind of bearing required very low level of maintenance. Only you have to feel to control the level of oil, check the leak if there is any leak, and control the temperature. That's all. We don't need much further maintenance. And even if there is some kind of small vibration or anything, this kind of bearing can absorb it. Not like the ball bearing, it will be damaged. And the running hours for this bearing, it's for life, not like the ball bearing. For example, it will run for 20,000 hours. So for this bearing, it's mandatory to maintain it properly, to take care about it, and to avoid this kind of damage. Are we clear with our alternator? Gentlemen.
Perfect.
Yes, sir.
Perfect.
Okay.
Yes. Perfect.
Okay. Now after that,
what is the reason
when the
to
power
have such damage?
say again.
Excuse me, what is the reason to have such big damage in this bearing?
Lubrification.
Only lubricating? Maybe oil
100%.
is not clean enough?
No, if oil is not clean enough, and lubrication. If you are not controlling the level, because you can see here there is like one small dial to check the oil level, and if you are not you are not monitoring your oil level and go down, directly it will be damaged.
Thank you.
Okay. Once we control our power generator, we have to distribute it, and before that we have to. So we have to control it. So from generator directly coming to our main switchboard. The main switchboard is a piece of huge box with some bus bar inside. So this is the bus bar what we have inside. We are not having cable, we are having bus bar. That's why I'm telling you, avoid to open and touch during power. There is no cable and it is directly exposed. So there is no protection. Only expert people, they can open and take some image inside, but no one can approach. You will have all your power on this bus bar, and this is naked wire, nothing. There is no protection there. All our power will reach our main switchboard. Then what we have on our main switchboard, we will have our meters. And we have breakers. And as I told you, we have for every system, we have to monitor it and control it. So to monitor our generator output, we must have our voltmeter, our ampere meter, our kilowatt meter, and then more than that, if required to run 2 generators in parallel, we must also have another monitoring system to monitor if these 2 generators are safe to run in parallel or not. We must have the reading of our power factor. Jens, are you familiar with this system or not?
No for me.
Okay. Okay. Do you know what is the procedure to run 2 generators in parallel? Because we will not make one generator.
I think there is a switchboard between the two generators. If we wanted to shut down one of them, electricity won't go down.
We are not going to shut down. We are not going to shut down. We are going to run both of them in parallel. Keep in mind, for example, if our requirement on board the vessel is, for example, 1000 kVA, we will not have one generator 1000 kVA. We will have, for example, 2 generators, each one 600 or 700 kVA. So this is the way how we at least we can, if we will not have all the time 1000. So we will have our for example
70%.
we will have 70%. So once for example only during maneuvering we will run all our equipment, and then we'll have our 100% load, and only that time we'll have 2 generators. So to run 2 generators in parallel, what will be required?
The first thing that the generator that I want to pre-run alongside with the generator I'm using, I have to prepare it to run to make it run. Then I divide the loads of the both generator.
Before reaching that, what you have to do? Before reaching to share the load, how to couple both of them in parallel? What you have to do? What is required to couple two generators in parallel?
I don't remember their names exactly, but
Okay. Okay.
No,
I
I
will,
don't.
yes, it's okay. Never mind. Okay. The alternator, from alternator, we can control the voltage. And from the engine side, through the governor, we can control the RPM. RPM is cycle, how many hertz? For example, 50 cycle mean 1,500 RPM. 60 cycle is 1,800 RPM. This is the common. Can be 900, can be another value. Depends on number of pole in each rotor. Let's go with the standard one. The standard one is 1,500 and 1,600. So at 1,800, we are having 60 cycle. And the RPM is controlled by our governor, right? So to couple two generators in parallel, we must have the same frequency, the same RPM, and then we'll have the same voltage, from AVR.
Yeah.
And the third thing, we have to match. We have to match the sequence of each sinusoid per phase. We have to match them, and for that we will just increase or decrease a little bit the RPM till we match both of them, and that time we will couple. Same. If you are going for the automatic one, say
the three lows, right? The same frequency, same hertz, and same voltage.
Yes.
I remember. Yeah, I remember it. Okay.
Yeah. Okay, so for that, to reach this point, because this is part of crucial point on board your vessel, you need the generator to run in parallel. So you must go to calibrate all your equipment. That's why. And then to check your breaker. Okay, so the first of all, our main switchboard, we have to maintain it properly. So this bus bar, as I told you, when we will perform our thermographic survey, we will check if there is some hot point, and then the hot point means some loose connection. And then what we have to do, we have to retight. So we will have in our scope main switchboard cleaning and retightening. So we will make blackout. All the vessel will be out of power. We'll arrange some temporary light, and we have to clean it properly and to retight all this bolt. Any loose connection means we will create a hot point, and then the hot point will melt the metal and can create some fire there, and all your switchboard will go. So it's mandatory to have your switchboard cleaned and all the bolts checked. Okay.
Yeah. Okay.
The second thing, our meter, because we are getting the reading through our meters. For example, if you are going to connect two generators in parallel, you must have the same reading. And if one of them is having some reading error, you cannot couple both of them in parallel. That's why you have to remove your meter and to take it to some 1 voltmeter master, and then to calibrate them. If in any case you have a doubt about your meter, and during sailing of your vessel, you can do one option: use the same multimeter to measure the same one. Use your same multimeter to check the voltage in each alternator. Do not lie on the main switchboard meter, because if you are using the same tools, you can check if the reading is accurate as the main switchboard voltmeter or not. This is one way. Otherwise, during any docking, try to go to perform the calibration of all meter on your main switchboard. If you are having some system couple in parallel your generator, you will not be required to go through calibrating all of them, and it will be depend on the surveyor and the class requirement. Okay, so
excuse me.
tell me.
Yes, but I heard about some kind of a special board that can manage automatically between the two generators. Is that
Yes.
correct? Or?
Yes, this is what you have this picture, what the guy is doing. This is this kind of device. It will, it's like a control and monitoring system for the alternator, and then it will couple of them in parallel directly. So whenever the power is going exceeding, for example, the 70%, automatically another generator will be running, and after, for example, 10 minutes, directly it will be coupled. So this is the automatic one. And you can see the engineer here is configuring the generator and checking the system is working properly or not. Now, almost the technology is going to have everything controlled and monitoring, and we have access to check if it is performing, it is working well or not by computer, not like the old school. So you can see here from one side you have the old school, from the other side you are having the new technology and what is implemented in the new switchboard. There is so many manufacturers of this system. There is Dave, there is Woodward, there is so many brands, and all of them are providing this kind of solution. So it will make your life more easy on board, and they are avoiding any human error.
Yeah, but is there any disadvantage for this system?
Disadvantage if you have some reading error. So it can spoil your system or it will not work. The system are made safe and approved. So I can't see any disadvantage. Disadvantage is there is no no human error there. There is no advantage. There is no disadvantage.
Okay, thank you.
Okay. Okay, so for the main switchboard, the best option is to go to calibrate all our equipment and to clean and tight all the bus bar and our switchboard, because this is the main power controlling. Okay, so now we have the power generator, we have the power connected in our switchboard, and then it will be distributed through the motor control unit. If you are discussing about motors, we have the lighting circuit. It will be through one transformer, and then we will generate the 220 volt. Some vessels they utilize the 110 volt. It will be same through one transformer, and then we will generate our 110 volt. And I didn't. Okay, so I missed to put some other picture of switchboard. You can see how it is divided, because you will have many other. For example, here you can see the switchboard are only made for the generator, but you will have in the same our control room, you will have other switchboard for the 440 feeder, for the 220 feeder, for the 110 feeder if we have, and then for our motor controlling. So you will have more other switchboard, not only this the one related to the generator. And then come to now we monitoring our system and how to control it. We control it through the breaker. So for that you have to, it's mandatory every for example 1 year to go to check the integrity of your system, because this is your safety device. It is working properly or not. If there is any failure, because if this breaker is not tripping, you'll have you cannot engage or disengage your alternator, and then you will have a hazard. So we must check if our breaker is working properly or not, and it is following, for example, because there is thermal protection and there is load protection. So both of them we have to check it. There is two options to control, to check our breaker working properly or not. The first option will be through secondary injection. And this is like using like a computer device. We will inject through the secondary coil, because inside there is some coils, and this is the one who will take the unit. Or we have to give exactly the power from backside. For example, if your breaker is, for example, 1000 ampere, you have to give the 1000 ampere and to check if it is after at 10% it will trip or not. And we have some setting here. You can see in this breaker. It can be done only by specialists, and after that it will be sealed, and one certificate will be released. So it is, as a chief engineer on board, you have to put the breaker servicing and testing and report to be generated in your scope. You will have the main breaker. Like, for example, we'll go for the previous picture here. Okay, you'll have the, if you can see the main switchboard, you will have for each generator one breaker, and then you have your emergency switchboard. Between the main and emergency, you will have another breaker. We call it tie breaker, and then you will have, for example, if your main switchboard is bigger than it's double size. Between the two switchboard, you will have another tie breaker. So you will have so many, and all of them will be almost the same size. Okay, the next step will be to, as per the list of your motor, when you establish it, you have to prepare the list of the critical motor that require to be overhauled. And for that, we must know how our motor are, what kind of motor we have, and what is required. Depend on your motor location. All motors are not same. So, for example, the Boston store will have some kind of explosion-proof motor. On VLCC, for example, for the pump room, you will have some explosion-proof motor. The design will not be the same. The procedure of overhauling will not be the same. Here I keep two types of motor: the 220 volts and the single phase and the 3-phase. How we know which one is single phase, which one is 3-phase motor? Gentlemen.
By the pools.
How we know which one is single phase, which one is 3-phase? How we know?
By the pools.
What pools?
The motor pools.
No. Okay, here you have three picture of motors.
What?
Which one is single phase? Which one is 3-phase?
Okay. The lowest one, the one at the bottom, is the 3-phase.
Okay.
Okay. And the one on the right, upper right, is single phase. And the one on the left, the upper left, is single phase also. No.
Okay. We have the upper one, the dismantled one. It is single phase because there is capacitor. Single phase will be one capacitor there. So whenever you have one motor with capacitor, it's single phase. Without capacitor, you cannot start the single phase motor. You need capacitor. How to start it? So the 3-phase motor are without capacitor. The single phase motor, all of them are with capacitor. Any motor you go around the world, it will be with capacitor. Only for the small kitchen motor, it will be the small teeny one. It's without. Otherwise, and for the single phase motor, you will have at the stator 2 winding. At the 3-phase motor, you will have 3 winding, 3 coil. The single phase motor are designed to start with 1 coil and capacitor, and the second only for starting system, and then after starting, the other coil will keep running the motor. 3-phase is coming only with 3 coil, and if it is double speed, it will be 6 coils. So the first of all, you have to know, you must have record of all your motors, mega reading and vibration, and then to check what location of your motor, what is the criticality of your motor. Some motors, for example, for VSCC, if the pump probe is not working, the vessel cannot sail. It cannot deliver any product. It cannot. So for the steering gear motor are one of the critical motor. You need it. Without steering gear, you cannot. You are having 2, yes, but you sometimes you need both of them, and you will have the best opportunity to overhaul them will be at dock. For the main engine, we will have our auxiliary blower. So this is the best opportunity. You have your engine down, take them and overhaul it. The lube oil, the cooling line for all your equipment, because at a dry dock you can ask for cooling line and then dismantle, do all the related work to your cooling system, seawater cooling system. Your fire line, same. You have to stop your fire pump and then go for the fire pump motor overhaul. The main engine lube oil, same. Your engine is down, just take the motor and overhaul. So all these motor is the best opportunity, the one stop at a dry dock to dismantle and overhaul them. During dismantling, as a chief electrician, you have to follow some procedure. Do not allow anyone to touch your motor, any motor, without your knowledge, because you have to isolate it, and you have to put the breaker on, and you have to lock it. Going to your main switchboard, you have to get one lock and lock the breaker, so nobody can power on. Because in your switchboard, power will be anytime. Power will be there. So if someone will put the power on, and if there is nothing connected at the other end, you will have some hazard. So as chief engineer, you must have your master list of all motor what will be disconnected, and then lock all the breaker. Use a lock, use a padlock. There is special lock to lock the breaker. So during dry dock, you use some kind of padlock and lock your breaker, so no one can put it on, and you will be on safe side. Motor will be removed to workshop. You have to visit them and check what kind of damage they have, because they will start dismantling and going in the process of overhauling. Before that, they will not start doing any repair without your knowledge. Just a minute. And you have also advised the shipyard if you are having any failure. For example, if you are having some vibration or some low mega reading in one of these motor, just let them know. It will guide them further to perform some extra tests, because any test the shipyard will perform, it will be costing money. So in one way to save money, just you will not ask them to do all the kind of testing. They can go for core test for the stator, the core test for the rotor, check if there is some going for some trueness, if the rotor is bent or not. So all this kind of tests. It will be not necessary to go through it. But if you have any failure and you record during your record, just let them know, and it will help. It is like one teamwork. Based on your condition report, because the shipyard will try to make your motor as coming from manufacturer. If there is any damage, they will check the bearing housing, the bearing journal. You know what this means or not? This bearing, when we will remove, we call it the bearing journal, where the bearing is sitting there. Sometimes it can be wear down. It can be some damage. So we at the shipyard, they will take the record and they will check as per the manufacturer, as per the bearing manufacturer, it is in tolerance or not. And then they will advise you. They have to go for some repair. They have to go for some electroplating. Some depend on what, how big the damage. Other than that, you must have proper cooling for your motor, like this fan and the fan cover. It is mandatory to have it there. Only for engine room fan, sometimes because it's already there is some air blowing and it can be cooled. Your motor is designed to be cooled, so we must have our cooling for our motors. One more thing, as I told you, depend on your motor location. You have also to check the gland. You know this part? This is the part we call the gland, where the cable is passing. If you are dealing with some explosion environment like pump room, the gland also must be explosion proof. Otherwise, you cannot fit any gland. We have received from some ship, I don't know, based on what, some people, they change the gland blindly without checking or reading. Keep in mind, there is a rule for every electric system on board, for cables, for gland, for motor, how the motor is sitting, how the motor is cooled. There is rules for everything. Everything in details you will have. If you go through the standard, you will have something writing about and some guidance. Now we go through all this. All the previous one can be done during berthing when you are at the dry dock, at any shipyard, and during your berthing period, perform all this job. You can perform it. Then once we take the vessel outside the water, when the vessel enters the dock, then we'll go for the docking item. The docking item will be mainly because we will to prevent our hull, paint, piping. We must have some cathodic protection, and for that we will use what we call the ICCP. It's cathodic protection. It's before we are using some sacrificial anode like aluminium and zinc. And then with technology, we find that this anode can be consumed quickly, and some material cannot be properly made, and some improperties there. So the best option is to go for some electric device to create some like field to protect our hull from any rust or to prevent that. For that, we are using the one system, the impression current protection system. So this is the one what we are using on board. During dry dock, first of all, go with the manufacturer and ask him to inspect the vessel before entering the dock. And then he will generate the report, what will be required to be done. Once the vessel enters the dock, you must know exactly, because you have seen some anode and some reference anode are fitted on board. So it will be inside one cofferdam, one small box. From outside, you will have the shield area with your anode. From the inside, you will have one box, and it is watertight. This box will be watertight. During dry dock, you have to inspect this box if there is some water increase inside or not, if there is some rust, and then to be clean. And based on the technician report, he will advise if the anode is still working perfectly or not. Before this anode was dock item, but now with the new technology, it become no, because still we are having some the cofferdam is a small box and it is closed. So when even we can disconnect the anode from inside, close back the cofferdam, and this anode is bolted and with rubber, so easily can be taken, fitted back, and then after open this cofferdam, take all the water what will be inside, and then connect it back. So before it was a dock item, now it's almost not 100% dock item, and we can even use a diver to get the job done. The system to continue working, we will have the tail shaft grounding connected back to the system, because you have to, when we have one circuit, We have to start with anode and then going through the hull and back to the tail shaft grounding. So you can see here the carbon, this brush holder. It will be connected to the tail shaft. This is one of the systems to be inspected and checked during dry dock. The next system will be the marine growth. In our sea chest or in our strainer, you will have some anode fitted. It can be aluminium copper anode, or it can be copper anode. If you're, for example, this case, you are having both copper anode to protect our sea chest cooler. The common system, what we are having almost in 90% of the vessel, we are having in one strainer. We are having this one aluminium and one copper anode. It will kill all the shell and the growth, and then you will have your piping safe. Otherwise, if the system is not working, so many growth will remain inside, and the system, the piping system can be closed and damaged and choke. So you will not have enough. It can be not a dock item if you are 100% sure that your valves are working properly. But only to avoid this, better to do it during dry dock, because your main cooling line is or the main valve, the sea chest valve, is connected. If you have any failure, you cannot stop. You don't have any other backup. So better to do the strainer MGPS during dry docking. The other docking item what we have is the speed lock. Speed lock, we have, it's also the tool is using to record the vessel speed, and then we are having one valve to overhaul, because the transducer will go through the valve. So during docking item, this valve will be taken out for overhaul, and our transducer will be taken. It cannot be a dock item if you are 100% sure if the valve is 100% tight and will hold the water. Otherwise, it will be considered as a dock item, because during docking, mechanical, they will will take this valve for overhaul. Then you have to remove your speed lock. Then you have the EcoSounder. EcoSounder, for the EcoSounder, it's almost the same, but you have the transducer, but it is mounted from down, and we will not have any access to take the. So it is 100% docking item for the EcoSounder. Gentlemen, I believe we are done. So if you have any question, if you are looking for something else, we can.
Yes, please. Can I ask about this protection system, the electric protection system?
Yes, we can make a session especially for this cathodic protection system, because it's huge, and we will go in detail, and I will explain you how the system is working. But as of now, the system, I can give you only the rough idea how the system is working. You will have we have your reference anode. This is the one, this reference cell. You'll have your reference cell. This one will measure how much current we are injecting at the hull. And then through this anode, we will like spread some electricity in our hull. When we spread the electricity in our hull, no growth will come and stick in our hull. This is the option one. The second one, your paint and the metal it's inside the water, so we'll have some corrosion. Corrosion means we are placing some electron from between our steel to with the seawater, and then the corrosion starts. With this system, we are supplying this electron, so we will stop the corrosion. Even if the paint is gone, we will stop the corrosion.
Yes,
I know I am a little bit brief, but if you want, we can go further with this kind of details, because it will take more time to explain that.
Okay, so basically this electricity are very limited, and there is no risk for any danger if someone
It
died
will,
in it.
yeah, it will be almost 24 volt and 200 ampere. The 200 ampere will create like, as you can see this in the lowest picture, it's like if like propagation of all your HAL. It will not affect anyone. It's low voltage. It's very low voltage.
Okay, thank you very much.
Welcome.
Thank you. I appreciate your answer. Thank you.
Thank you, gentlemen. I hope you find it interesting, and thank you for your attendance, and see you.
Thank-
Ahmed, you have
Thank you,
anything?
sir.
Thank
For the
Thank you for your time.
Thanks a lot, Ahmed, for the valuable information.
Raisha, what you are doing here? Okay, see you, gentlemen.